Hi guys, tonight we're exploring one of the most fundamental questions about existence. What if reality isn't made of matter or energy, but of sound? What if everything around you is actually vibration, frequency and resonance, creating the illusion of solid reality? If you enjoy these reality questioning sleep stories that explore the nature of existence, hit that like button and subscribe for more. And drop a comment letting me know what time it is, where you are, and where you're listening from. I love hearing from philosophical minds worldwide. Alright, let's begin. Imagine for a moment that you're standing in a vast cathedral, its Gothic arches stretching impossibly high above you, and you strike a single, pure note on a tuning fork. The sound ripples outward, bouncing off stone walls, creating harmonics and overtones that seem to breathe life into the very architecture around you. Now imagine that this sound, this vibration, this wave of energy moving through space, is not merely travelling through reality, but actually creating it, moment by moment, frequency by frequency. What if the solid ground beneath your feet, the air in your lungs, the thoughts in your mind, and the stars wheeling overhead were all nothing more than different frequencies in an infinite cosmic symphony? This is not merely the stuff of science fiction or mystical speculation. Across the globe, from the laboratories of theoretical physics at CERN in Switzerland, where scientists accelerate particles to velocity approaching 299,792,458 meters per second, to the meditation halls of Tibetan monasteries where monks chant at frequencies measured precisely at 110 Hz, a revolutionary understanding is emerging. Reality, at its most fundamental level, might indeed be sonic in nature, a vast harmonic structure where matter, energy, space and time are all manifestations of vibrational phenomena. Consider the extraordinary implications of this possibility. If reality is fundamentally made of sound, then the universe is not a mechanical clockwork of particles and forces, but rather an immense musical composition, with every atom vibrating at its own unique frequency, every molecule contributing to complex harmonics, every living being adding its voice to a cosmic orchestra of unimaginable complexity. The hydrogen atom, the most abundant element in the universe, comprising roughly 75% of all normal matter, would vibrate at approximately 1.420 MHz. The carbon atoms that form the backbone of all organic life would resonate at different frequencies entirely, creating the harmonic structures that we experience as DNA, proteins and ultimately consciousness itself. In the laboratories of quantum physicists, experiments have revealed that subatomic particles behave in ways that seem almost musical in nature. When electrons orbit atomic nuclei, they can only exist at specific energy levels, much like the discrete notes on a musical scale. These quantum energy states create what physicists call standing waves, patterns of vibration that are stable and persistent, much like the harmonics produced by a violin string. The electron configuration of gold, element 79, creates a complex harmonic signature that might explain why this metal has captivated human beings for over 4,000 years of recorded history, resonating with something deep in our sonic nature. String theory, perhaps the most ambitious attempt to unify all of physics into a single framework, proposes that the fundamental constituents of reality are not point particles, but tiny vibrating strings. These strings, existing at the Planck scale of 10 to the negative 35 meters, would be so small that if an atom were enlarged to the size of our solar system, a string would still be smaller than a tree on Earth. Yet these infinitesimal vibrations would give rise to all the particles and forces we observe, each frequency corresponding to a different particle type. The photon, carrier of electromagnetic radiation would arise from strings vibrating in one mode, while the graviton, the hypothetical particle that mediates gravity, would emerge from an entirely different vibrational pattern. If we follow this sonic interpretation of reality to its logical conclusion, then what we call solid matter becomes a kind of acoustic illusion, a standing wave pattern so stable and persistent that it creates the experience of solidity. The steel girders supporting a skyscraper like the Burj Khalifa in Dubai, rising 828 meters into the sky and weighing approximately 500,000 tons, would be nothing more than incredibly complex harmonic structures, frequencies locked into patterns of extraordinary stability. The concrete foundation, extending 60 meters below ground, would represent bass notes in this architectural symphony, low-frequency vibrations that provide the harmonic foundation for the higher frequencies of the tower's steel and glass superstructure. The implications for our understanding of consciousness become particularly profound when viewed through this sonic lens. The human brain, containing approximately 86 billion neurons, each firing electrical impulses at frequencies ranging from 1 to 100 Hz, creates patterns of neural oscillation that neuroscientists are only beginning to understand. Gamma waves, oscillating between 30 and 100 Hz, appear to correlate with conscious awareness and binding different sensory experiences into unified perception. If consciousness itself is a sonic phenomenon, then thoughts, emotions and memories might be understood as complex musical compositions played out across the neural networks of our brains. This perspective transforms our understanding of mental illness and healing. Depression, affecting over 264 million people worldwide, according to the World Health Organization, might be understood as a kind of discord in the brain's harmonic structure, certain frequencies becoming dampened or distorted. Anxiety disorders, experienced by approximately 40 million adults in the United States alone, could represent excessive resonance in particular frequency ranges, creating feedback loops that amplify worry and fear. Music therapy, which has shown measurable neurological benefits in treating conditions from Alzheimer's disease to post-traumatic stress disorder, might work by providing external sonic structures that help restore harmonic balance to disrupted neural oscillations. The ancient traditions of sound healing take on new significance in this framework. Tibetan singing bowls, crafted from alloys containing 7 different metals corresponding to the 7 classical planets, produce complex harmonic overtones that practitioners believe can align the body's energy systems. Scientific measurements of these bowls reveal fundamental frequencies typically ranging from 110 to 660 Hz, with overtone series extending well beyond the range of human hearing into ultrasonic frequencies above 20,000 Hz. Aboriginal Australians have used the didgeridoo for over 40,000 years, creating circular breathing techniques that produce continuous drones, rich in harmonic content, with fundamental frequencies typically between 65 and 200 Hz. If reality is sonic in nature, then these ancient practices might represent sophisticated technologies for manipulating the fundamental frequencies of matter and consciousness. The Great Pyramid of Giza, constructed from approximately 2.3 million limestone blocks, weighing between 2 and 15 tons each, exhibits acoustic properties that modern architects and acousticians find remarkably sophisticated. The King's Chamber resonates at a frequency of approximately 438 Hz, while the entire structure appears designed to amplify and focus sound waves in ways that suggest an advanced understanding of sonic engineering. The economic implications of a sonic reality would be staggering. The global music industry, currently valued at approximately $25.9 billion annually, represents only the tiniest fraction of what might become possible if we could directly manipulate the frequency signatures of matter itself. Imagine being able to transmute elements by altering their harmonic structures, converting common silicon dioxide, which makes up roughly 59% of the Earth's crust, into precious metals or rare earth elements simply by applying the correct sonic frequencies. The global rare earth elements market, currently worth $4.4 billion per year and dominated by Chinese production of approximately 140,000 tons annually, could be revolutionized overnight. Agriculture might be transformed through what could be called sonic farming, using specific frequencies to stimulate plant growth, enhance nutrient uptake, or even alter genetic expression. Studies have already shown that certain sound frequencies can increase crop yields by as much as 20%, with tomato plants exposed to 1 kHz sine waves showing significantly improved growth rates compared to control groups. If plants and their cellular structures are fundamentally sonic phenomena, then the global agricultural output, currently feeding 7.8 billion people with an annual grain production of approximately 2.7 billion tons, could potentially be multiplied several times over through precise acoustic interventions. The construction industry, representing approximately $13 trillion of global economic activity, might develop entirely new methodologies based on sonic manipulation of materials. Instead of mining, refining, and shaping materials through mechanical and chemical processes, buildings might literally be sung into existence, their molecular structures assembled through carefully orchestrated frequency patterns. The carbon footprint of construction, currently responsible for approximately 39% of global carbon dioxide emissions, could potentially be eliminated if materials could be assembled from atmospheric components using only acoustic energy. Transportation systems might operate on entirely different principles if the sonic nature of reality could be harnessed. Instead of burning fossil fuels or storing electrical energy, vehicles might manipulate their own frequency signatures to achieve levitation and propulsion. The global transportation sector, which currently consumes approximately 28% of global energy production and generates roughly 16% of greenhouse gas emissions, could be revolutionized. Imagine aircraft that fly not by pushing against air with wings and engines, but by harmonically aligning their sonic signature with the frequency patterns of the atmosphere itself, achieving flight through resonance rather than resistance. The field of medicine would undergo perhaps the most profound transformation. If diseases represent discord in the body's harmonic structure, then healing might become a matter of identifying and correcting specific frequency imbalances. Cancer, which affects approximately 18.1 million people globally each year, might be understood as cells whose sonic signatures have fallen out of harmony with the surrounding tissue. Instead of chemotherapy, radiation, or surgery, treatment might involve exposing tumours to precisely calibrated sound frequencies that restore normal cellular oscillation patterns. Infectious diseases take on a different character in a sonic universe. Bacteria and viruses would have their own characteristic frequency signatures, and immunity might be understood as the body's ability to maintain harmonic coherence in the presence of discordant acoustic elements. The SARS-CoV-2 virus, with its distinctive spike protein structure, would resonate at specific frequencies that disrupt the normal sonic patterns of human cells. Vaccines might work not by introducing antigens to stimulate immune responses, but by teaching the body's acoustic systems to recognize and counter specific viral frequency patterns. Mental health treatment could become extraordinarily precise. If thoughts and emotions are sonic phenomena, then conditions like schizophrenia, affecting approximately 20 million people worldwide, might be treated by identifying the specific frequency distortions that create auditory hallucinations and delusional thinking. Instead of psychiatric medications that affect broad neurotransmitter systems, treatment might involve targeted acoustic interventions that restore normal brainwave patterns with surgical precision. The implications for space exploration become mind-boggling when considered from this sonic perspective. If matter is condensed sound, then spacecraft might not need to carry physical materials for construction and repair. Instead, they could carry frequency generators capable of manifesting needed materials from the quantum foam of empty space itself. The International Space Station, currently weighing approximately 450 tons and costing over $150 billion to construct and maintain, might be replaced by structures that exist primarily as stable acoustic patterns, requiring minimal physical matter to maintain their integrity. Interstellar communication, currently limited by the speed of light with messages to our nearest stellar neighbour Proxima Centauri taking 4.2 years each way, might become instantaneous if information could be transmitted through quantum acoustic entanglement. The 70-metre radio telescopes of the Deep Space Network, used to communicate with spacecraft across the solar system, might be replaced by sonic transmitters capable of modulating the fundamental frequencies of spacetime itself. The search for extraterrestrial intelligence takes on new dimensions in a sonic universe. Instead of listening for radio signals, we might need to develop instruments sensitive to the acoustic signatures of alien technology and consciousness. Civilizations might communicate through modulations in the cosmic background radiation, currently measured at 2.7 Kelvin throughout the universe, using it as a carrier wave for complex harmonic messages. The WOW signal detected in 1977, lasting 72 seconds and originating from the direction of Sagittarius, might have been exactly such a communication, a brief sonic hello from beings who understand reality's acoustic nature. The environment and climate systems reveal new layers of complexity when understood sonically. Global warming, with atmospheric carbon dioxide levels now exceeding 415 parts per million for the first time in over 3 million years, might be addressed not just through emissions reduction, but through acoustic interventions that alter the vibrational properties of greenhouse gases. The frequency signatures of carbon dioxide molecules might be modulated to reduce their infrared absorption characteristics, effectively tuning the atmosphere to achieve optimal thermal balance. Weather modification becomes theoretically possible through large-scale acoustic engineering. Hurricane systems with winds reaching speeds of over 300 km per hour and releasing energy equivalent to multiple nuclear weapons every second represent massive acoustic phenomena. Their frequency signatures, spanning from infrasonic waves below 20 Hz to ultrasonic components above the range of human hearing, might be altered through coordinated sonic interventions, potentially steering storms away from populated areas or dissipating their energy harmlessly. Ocean systems containing approximately 1.37 billion cubic kilometers of water and covering 71% of Earth's surface would represent vast acoustic reservoirs. The songs of whales, particularly the deep infrasonic calls of blue whales that can travel thousands of kilometers underwater, might serve as natural probes of oceanic acoustic conditions. These marine mammals, the largest animals ever to exist with hearts weighing as much as 600 kilograms, might be inadvertent acoustic engineers, their vocalizations helping to maintain the harmonic balance of ocean systems. The geological processes of Earth itself take on new meaning in a sonic framework. Earthquakes, which release energy equivalent to multiple nuclear weapons and affect millions of people annually, represent sudden releases of accumulated acoustic tension in the planet's sonic structure. Seismic waves traveling at speeds of up to 8 kilometers per second through the Earth's interior might be understood as the planet's way of maintaining harmonic balance, redistributing acoustic energy to prevent larger dissonances from building up in the geological system. volcanic eruptions like the Tambora explosion of 1815 that released energy equivalent to 60 million tons of TNT and affected global climate for years afterward, would represent the Earth's sonic signature reasserting itself after periods of harmonic build-up. The Ring of Fire around the Pacific Ocean, containing 75% of the world's active volcanoes, might be understood as a vast acoustic organ where the planet processes and releases harmonic tensions accumulated from tidal forces, solar radiation, and the gradual cooling of the Earth's interior. The mystery of dark matter and dark energy, which together comprise approximately 95% of the universe's mass energy, but remain invisible to electromagnetic detection, might find explanation in sonic theory. These phenomena might represent aspects of the cosmic acoustic structure that vibrate at frequencies beyond our current ability to detect or measure. Dark matter, estimated at 27% of universal mass energy, might consist of acoustic patterns that interact gravitationally with ordinary matter but oscillate at frequencies that don't couple with electromagnetic radiation. Dark energy, apparently causing the accelerating expansion of the universe with a density of approximately 6.9 times 10 to the negative 27 kilograms per cubic meter, might represent the fundamental frequency of spacetime itself. As the universe expands, this acoustic substrate might be stretching to lower frequencies, creating the appearance of accelerating expansion while actually maintaining harmonic consistency across ever larger scales. The formation of galaxies and galaxy clusters, some containing thousands of individual galaxies spread across millions of light-years, might follow acoustic principles similar to those governing musical harmony. The Milky Way galaxy, containing between 100 billion and 400 billion stars arranged in spiral arms extending approximately 52,000 light-years from the galactic center, might represent a stable acoustic pattern, a kind of cosmic musical phrase that maintains its structure through gravitational harmonic resonance. Black holes, with masses ranging from several times that of our Sun to billions of solar masses, might be understood as acoustic singularities, regions where the normal frequency patterns of spacetime break down and collapse into infinitely dense harmonic nodes. The event horizon, beyond which nothing can escape, might represent the boundary where local acoustic patterns become so compressed that they can no longer maintain coherent information exchange with the broader sonic structure of spacetime. The recent detection of gravitational waves by the LIGO Observatory, measuring distortions in spacetime smaller than 1/10,000th, the width of a proton, provides tantalizing evidence for the universe's acoustic nature. These ripples in space-time, generated by colliding black holes billions of light-years away, literally cause the Earth to ring like a bell, vibrating at frequencies between 50 and 250 Hz. The fact that these cosmic events produce audible frequencies when converted to sound waves suggests deep connections between the large-scale structure of the universe and familiar acoustic phenomena. Quantum mechanics, with its seemingly paradoxical behaviors and probabilistic nature, gains new clarity when understood acoustically. Wave-particle duality, the puzzling observation that matter sometimes behaves like particles and sometimes like waves, becomes natural if everything is fundamentally acoustic. Quantum entanglement, where particles separated by vast distances maintain instantaneous connections, might represent resonant coupling in the universal acoustic field, similar to how striking one tuning fork can cause identical forks to vibrate sympathetically across a room. The uncertainty principle, which states that certain pairs of properties cannot be precisely measured simultaneously, might reflect the fact that acoustic phenomena require time to develop and cannot be frozen into static states. Just as you cannot capture the full harmonic content of a musical note without allowing it to sound for some duration, quantum properties might be fundamentally temporal and acoustic in nature. requiring observation over extended periods to reveal their full character. The implications for human evolution and development become fascinating when considered from this sonic perspective. Archaeological evidence suggests that early human development of language, music, and tool-making occurred simultaneously, approximately 50,000 years ago. This might represent the period when our species learned to consciously manipulate acoustic phenomena, developing both vocal communication and rhythmic tool use as expressions of our growing mastery over reality's sonic nature. The development of written language, beginning approximately 5,000 years ago with cuneiform scripts in Mesopotamia, might represent humanity's first attempts to create visual representations of acoustic information. The alphabet systems that followed, including the Phoenician script that became the ancestor of most modern writing systems, encode the sonic elements of speech into visual symbols, suggesting an intuitive understanding of the fundamental relationship between sound and information. Musical traditions across human cultures show remarkable similarities despite developing in isolation over thousands of years. The octave, representing a frequency ratio of 2:1, appears in virtually every human musical system. The pentatonic scale, built from frequency ratios based on simple mathematical relationships, emerges independently in cultures from ancient China to pre-Columbian America. These universal patterns might reflect our species' intuitive recognition of the acoustic principles underlying reality itself. The architecture of sacred spaces across cultures reveals sophisticated understanding of acoustic principles. The Whispering Gallery of St. Paul's Cathedral in London, where sound spoken softly at one point can be clearly heard 34 metres away on the opposite side of the dome, demonstrates practical mastery of acoustic focusing. The Mayan pyramid at Chichen Itza produces distinct acoustic effects, with clapping hands at the base creating echo patterns that sound remarkably like the call of the sacred Quetzal bird. These architectural achievements suggest that ancient builders possessed advanced knowledge of how sound interacts with physical structures. Modern neuroscience is revealing that brains might indeed operate as sophisticated acoustic processing systems. Neural synchronization, where different brain regions coordinate their electrical activity, appears to be fundamental to conscious experience. The default mode network, active when the brain is at rest, shows coherent oscillations at frequencies around 10 Hz, similar to the alpha waves associated with meditative states. These discoveries support the possibility that consciousness itself might be an emergent property of neural acoustic synchronization. The therapeutic applications of sonic medicine are expanding rapidly. Focused ultrasound, operating at frequencies above 20,000 Hz, can now destroy tumor cells without damaging surrounding tissue, break up kidney stones, and even temporarily open the blood-brain barrier to allow medications to reach previously inaccessible areas. Transcranial magnetic stimulation, which uses rapidly changing magnetic fields to induce electrical currents in specific brain regions, might be working by disrupting pathological neural oscillation patterns associated with depression and other psychiatric conditions. Sound baths and frequency healing, once dismissed as pseudoscience, are gaining recognition as legitimate therapeutic modalities. Studies show that exposure to specific frequencies can measurably alter brainwave patterns, reduce stress hormones like cortisol, and promote the release of endorphins and other beneficial neurotransmitters. The frequency of 432 Hz, considered by many sound healers to be particularly harmonious, produces measurable relaxation responses when compared to the standard tuning frequency of 440 Hz used in most Western music. The global implications of recognizing reality's sonic nature would be transformational beyond anything in human history. International cooperation would become essential, as nations realized that acoustic interventions in one part of the world could affect the harmonic balance of the entire planet. The United Nations might need to establish new frameworks for governing acoustic technologies that could alter weather patterns, influence geological stability, or affect the consciousness of entire populations. Economic systems based on scarcity of physical resources would give way to new models based on information and acoustic expertise. The most valuable commodities would become frequency patterns and acoustic technologies rather than raw materials. Educational systems would need complete restructuring to teach acoustic literacy alongside traditional subjects, helping people understand and interact consciously with reality's sonic nature. Religious and spiritual traditions would find validation for many of their core insights about the vibrational nature of existence. The Hindu concept of Om as the fundamental sound of creation, the Christian idea of the Word that brought reality into being, and indigenous traditions of singing the world into existence would be recognized as sophisticated understanding of cosmic acoustic principles. Prayer and meditation practices might be studied as technologies for conscious interaction with the universe's harmonic structure. The future of human consciousness might involve learning to perceive and interact directly with the acoustic substrate of reality. Children growing up with this understanding might develop enhanced abilities to sense and influence the frequency patterns around them. Human evolution might accelerate as we learn to consciously participate in the cosmic symphony rather than remaining unconscious players in its vast composition. As we stand at this threshold of possibility, imagining reality as fundamentally sonic in nature, we find ourselves not at the end of mystery, but at the beginning of a far grander adventure. If everything we experience is indeed music made manifest, then we are not separate observers of the universe, but integral voices in its eternal song. The boundaries between self and cosmos, between mind and matter, between science and spirituality, dissolve into the recognition that we're both the instruments and the musicians in a cosmic orchestra of unimaginable beauty and complexity. This vision of a sonic universe invites us to listen more deeply, to attune ourselves more carefully to the subtle frequencies that might govern our reality. It suggests that the next great leap in human understanding will come not from building more powerful machines to peer into the depths of space or the heart of atoms, but from developing more sensitive ears to hear the music that has been playing all around us, all along, waiting for us to recognize that we too are notes in the grand symphony of existence.